Alright, let's cover Chapter 7, Nomenclature. There are two parts of Chapter 7, Nomenclature, and we have some math a little bit later on. What is nomenclature? Nomenclature is considered the language of chemistry. Why is nomenclature important? Well, in chemistry, we used to give everything a common name. Vinegar, baking soda, different common names. Today, we have a systematic way of naming things. For example, people. We always give them a first name. Usually they have a middle name and then they have a last name. Just like in chem, that way we know which family they come from and all that good stuff, or we can just about approximate it. It's just as important to have a common naming system in chemistry, because if you can tell what's in the chemical formula from its name, you can derive its equation, its formula. Okay, I want to start off with molecular compounds, and we may need to review exactly what is a molecular compound first. Remember, molecular compounds have covalent bonds, which means that they share electrons in bonding. They are electrically neutral, and they form typically between two nonmetals. Alright, parts of a chemical formula. We have two parts of a chemical formula. We have letters, and then we have numbers. The letters are the chemical symbol of an element. Alright, the subscript numbers tell how many of each element we have in our formula. So this is a chemical formula. Alright, so we would have 8 carbon atoms and 18 hydrogen atoms bonded. Okay? So molecular nomenclature, how do we name things? We use what we call the prefix system for binary compounds. Alright, the prefix system uses a set of prefixes to indicate the number of atoms present. Alright, in writing the formulas, the least electronegative atom comes first. Then we add prefixes to indicate the number of atoms present. Now there is one exception when we do not use prefixes, and it's mono. We do not use mono when it's the prefix for the first element. And it'll make more sense here in just a second. And as in all naming, or all of our nomenclature, we're going to change the ending of the last element, or the second element, to IDE. Remember, binary compounds, we have two substances. Least electronegative atom comes first. Prefixes to indicate the number of atoms. Omit mono from the first one, and change the ending of the second one to IDE. Remember electronegativity. Your least electronegative atoms are down at the bottom. Your most electronegative atoms are up at the top. Right. Alright, so our prefixes. These are the Greek prefixes that we use. You need to learn these and memorize these by heart. I typically give a pop quiz on these. Mono is 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. Okay, we're going to be using these a good bit for the rest of the year, so go ahead, memorize it. We will probably have, we always have a quiz. So, all right, so let's practice naming from formulas. So we're going to start with the formula, and we need to get a name. All right. So our first element is carbon. All right, put it up there. Carbon. So we have one carbon, so that would be monocarbon. However, the exception is not to use mono on the first element. The next element is chlorine. Remember, we put chlorine, change the ending to IDE, so it will be chloride, and we have to tell how many chlorides we have. So we have 4, which would be tetrachloride. Alright, on the next one, we have 2 nitrogens, so it will be dinitrogen. And we have 1 oxygen, so it will be monoxide. Notice we omit one of the O's, so it's not monoxide. It's just monoxide. Alright, SF6. We have 1 sulfur, so that will be monosulfur, except we do not use mono on the first one. And we have 6 fluorines. So that would be hexa fluoride. Remember, always change the ending to IDE. A sulfur hexafluoride. So sulfur 6 fluorides. Alright, that's good if we're going from formulas to names. What about names to formulas? That's real easy. Okay? The first one up here is arsenic, which has the chemical symbol of AS, and then trichloride. So we have AsCl, then tri means 3. Then the next one, dinitrogen pentoxide. Nitrogen is N, di means we have 2, so N2. Oxide is oxygen, pent is 5, so that means O5. So we would end up with N2O5. Now, on the last example, tetraphosphorus dicoxide. Alright, phosphorus is P, tetra means 4, so we have P4. Oxide is O, deca means 10, so it will be O10. We would end up with P4O10. And this is how you name molecular compounds. I forgot to include 7 little items. There are 7 elements that can never be by themselves. They have to be either bonded to something or bonded to each other. We call them diatomic because if they're by themselves, that means that they're bonded to themselves. So there are 2 of them. Okay? Bonded to each other. And these are the diatomic elements. You need to go ahead and memorize them. What's an easy way to memorize them? Well, there are 7 of them. They start at number 7. Nitrogen has atomic number 7. They make a 7. And then don't forget about hydrogen. So we have 7 hydrogen. Start at 7. Make a 7. Hydrogen. Start at 7. Make a 7. And don't forget about hydrogen.